polynomial is called what? What do we call it when you're polynomial? Cubic. So this is a cubic polynomial. Given the cube at the right, you can multiply the three sides to get an equivalent form. So if I take x plus 2 times x plus 3 times x plus 4, let me do something different. If I want to take 2 times 3 times 5, do I take 2 times 3 and 2 times 5? If you have 2 times 3 times 5. No, that's not the distributive property. But what you do is you take 2 times 3 is 6 and take that answer times the 5. So guess what? You're going to do the same thing when you multiply. This is x squared, 3x plus 2x is 5x plus 6 times the x plus 4. Now, to multiply, I'm going to take the trinomial times x and the trinomial times the 4. So that's going to give me x cubed plus 5x squared plus 6x. So I took the trinomial times the x. And then I'm going to take the trinomial times the 4. Then what am I going to do? Combine like terms, okay? So you're going to get x cubed plus 9x squared plus 26x plus 24. Now here's what I want you to do. I want you to either use Desmos or your graphing calculator. And what we're going to do is we're going to put both of these on and show that they're actually the same. So I'm going to use Desmos, or you can use a graphing calculator. So I'm going to do y equals, we had x plus 2 times x plus 3 times x plus 4. And I'm going to blow this up just a little bit. Do you see that I had an x-intercept at -4, at -3, and +2? How could we have been able to tell those were the x-intercepts from the factored form? How would you just know that looking at the factored form? Good job. You said each of those factors equal to 0. Okay, so now watch this. I'm going to put the expanded form in now. The x cubed plus 9x squared plus 26x plus 24. Do you see, in fact, it mapped it right onto it? They're equivalent, okay? So this is the difference between what we would call general form and factored form. Okay, general form versus factored form. The factored form, the roots and the x-intercepts are all there for you to know about something called the short run behavior. And the short run behavior is what's happening near x values near 0. Later, we're going to learn about long run behavior, sometimes called end behavior, which we've already done that this year. The behavior for x values far from 0. So in example 1, it says identify the x-intercepts and the y-intercept. Then write the cubic function. So watch what we're going to do. What are the x-intercepts here? Can you tell just looking at the graph what they are? -2.5, 0, 3.2 comma 0 and 7.5 comma 0. What's the y-intercept here? 240. And we're going to write these as ordered pairs. Okay, we're going to write these as ordered pairs. So then here's the big idea. If I know the x-intercepts, I actually know the factors. If I know the x-intercepts, I know the factors. Just like in our problem above, where we had x plus 2 times x plus 3 times x plus 4, my x-intercepts were -4, -3, -2, okay? They're really the opposite when you write them in factored form. So now, here's what you're going to do, and I'm telling you for now, this is an x cubed, okay? And I want you to notice something. X cubes have a shape like this. And when you put a negative in front, it reverses it. Do you remember us talking about this earlier this year? So we had x even, negative x even, x odd, negative x odd. So this is an x cubed shape. So that's how I know there's not any more. Then what you're going to do to solve this is you need to find a. So you use any other labeled point other than your x-intercepts to find the a value. So I'm going to plug in 240. And then if x is 0, so you're definitely going to want your calculators. That's going to be 2.5 times -3.2 times -7.5. I'm going to pause a moment, and I want you to multiply out the right side, and then in your next step, solve it for a. Yay, seen some good work. All right, so I'm getting 240 equals, now it's a positive 60a, so a is 4. Now here's my equation. You're going to go plug it back into this one up here, where I put a star. There's your equation. Now, do you remember we did this with quadratics in our quadratic unit? So all you're doing is taking this up a level. We can do this with cubics, quartics, quintics. We can do this with any higher powered polynomial. All right, so here's what I want you to do. I'm going to pause a moment, and I want you to try the cubic on the right. Write down your x-intercepts, the y-intercept. Then find a point that's not an x-intercept. It will probably be your y-intercept. Write the standard equation in factored form from your x-intercepts, and then find the a value. It's not the same as the first one. Now, if you know that you're using x is 0, if you can go with me, you can skip a step here. And I'm getting a is negative 1.5. How many got there? Woo! Okay, awesome, awesome. So you're going to get y equals negative 1.5 times x plus 2.5 times x minus 3.2, x minus 7.5. Now, what I want you to do for a moment, because I'm planting seeds for where we're headed. These are both cubic, but one of them has a shape like this one on the left, and the one on the right is going like this. Why did they change directions? Yeah, Brendan? Not that the y is negative. The a is negative, right? Okay, the a is negative. Oops. Pull this back up. All right, so the a value changes the direction of your polynomials. But what was the same on both of these? The x-intercepts were the same, okay? So, note, the factored form of a polynomial tells you the zeros of the function and the x-intercepts of the graph of the function. Recall that zeros are solutions to the graph of f of x equals 0. Factoring, if a polynomial can be factored, is one strategy for finding real solutions. All right, so let's look at example 2. If I want to find the factored form, this one is x minus 2 times x plus 1. And here's what I want you to do. I want you to go to either Desmos or your graphing calculator, and I want you to put the original graph in and look at the x-intercepts. Okay? So I'm going to go to my Desmos, and let me clear this out. And when I do y equals x squared minus x minus 2. Oops, missed some of that. Now, on the TI-84s, okay, if you have a TI-84, once you put this in, there is a button at the top, your tippy top, that says Trace. Underneath Trace it says Calc. So on the TI-84s, if you're ever trying to find the zeros, if you press second in the trace, number 2 says 0. And then you can find your x-intercepts right there, okay? All right, but anyway, do you see I have one at negative 1 and at positive 2? So that verifies that I did that correctly. Now, in this one, we're going to talk about factoring by grouping. And factoring by grouping is when you have 4 terms. So let me show you how to do this, but don't forget about step 1. What is step 1 in factoring? Guess what? I have a GCF of x cubed, a 4. I pull the 4 out. I get 2x squared minus 9x minus 18. So then I'm going to use a different symbol here because I'm going to use parentheses inside. So I'm going to change this to a grouping. And factor by grouping, you pull out the GCF of x squared out of the first 2. You always write down the middle operation sign. Then I pull out a 9 and I get x plus 2. Do you see why that's an x plus 2 at the end instead of a minus 2? Because I pulled the minus out front. Then they both have an x plus 2. So I factor out x plus 2, and then what's left is x squared minus 9. Okay, this is called factor by grouping. Factor by grouping is when you have 4 terms. I'm not finished, but let me kind of go through this one more time because this can keep going. When you want to factor by grouping, you have 4 terms. You pull out a GCF across all 4, and then you take the first 2, pull out the GCF from the first 2 was x squared, and that left me with x plus 2. You have 3 operation signs between your 4 terms. You take the middle operation sign and just write it down. Then the GCF of the next 2 is a 9, and I get x plus 2. When the middle operation sign is a minus, that flips this one. All right, does anybody know what else can I do to factor here? There's something that's screaming at me. No, I'm trying to factor, not distribute. I don't want to multiply it back out, but how could I continue to factor it? Mia, what do you think? Yeah, do you see x squared minus 9 is a difference of 2 squares? All right, polynomials with real coefficients can be separated into 3 types. So let's use our highlighters. Polynomials that can't be completely factored with real numbers. Polynomials that can be factored, but some of the roots are not nice. And polynomials that can be factored the whole distance. So we're going to start with something we know. If you look at the graph of y equals x squared minus x plus 1, it does not cross the x-axis, so there are no x-intercepts. However, that doesn't mean there's no solutions or no roots. Watch what we can do. If I identify a is 1, b is negative 1, and c is 1, I can do quadratic formula to solve this over the complex numbers. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So that's 1 plus or minus. Now I'm going to get square root negative 3. Whoops. So this is 1/2 plus or minus radical 3 over 2i. So it does have 2 complex roots. Now this one has 2 x-intercepts. So let's take a look here. Now a is 1, b is negative 1, and c is negative 1. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So do you see that there are 2 real zeros, but they're ugly? Okay, they would be decimals if I had to go the distance. So there's complex, there's approximate real zeros. Now let's do the third one. I have 2 x-intercepts, but it looks like they're crossing neatly on integers. So let's take a look. A is 1, b is negative 1, and c is negative 2. So I get x equals negative b plus or minus square root b squared minus 4ac all over 2a. So that's 1 plus or minus 3 over 2. can actually figure out those answers. 1 plus 3 is 4. 4 divided by 2 is 2. 1 minus 3 is negative 2. Negative 2 over 2 is negative 1. So, here's a big idea I need to mention to you. If b squared minus 4ac is a perfect square, okay, and a perfect square is like 1, 4, 9, 16, 25, etc., then the quadratic factors. So do you remember how we did the discriminant in chapter 5? Well, something that would have helped us is if we looked at the discriminant and the discriminant was like 9 or 49 or 81 or 16 or 4, it was going to factor, okay? So those are your three options with, say, a quadratic. So let's look at example 3. If I want to convert to standard form or general form means multiply it out. So what you're going to do is you cannot multiply 3 things at once, but I can group 2 of them at a time. And it doesn't matter if you group the first 2 or the second 2 and then multiply by the third thing. When I have a monomial times 2 binomials, I like to do the binomials first. So, and I'm going to do the FOIL in my head and get x squared minus 3x plus 1x is minus 2x minus 3. Then distribute. 2x cubed minus 4x squared minus 6x. So converting to standard form just means multiply it out from your factored form. All right, without graphing, how would you find x-intercepts and y-intercepts? All right, so if I have, it's already factored, okay? It's already factored. How do you find x-intercepts? Good job. All right, to find the x-intercepts, let y equal 0. Now, do you remember we've done this like 4 or 5 times this year? Okay, so we're going to let y equal 0. Now, what's happening to the negative 2? What do I do with it? Okay, do you see the negative 2 doesn't have a variable with it? Okay, when you see just a constant, you can divide both sides by negative 2. Then you would set x plus 5 equal to 0, x minus 4 equals 0, 3x plus 7 equals 0. So I'm going to pause and let you solve those. If you're a fast worker, go ahead and start on your y-intercept. We'll review how to do that in a moment. If you have a lot of mental capabilities, like a lot that you can store in your head, it's absolutely fine to go from this line to your answers. Okay, if you can handle it, go for it. I personally, that's how I do it. But because I want to show everybody, and depending on what you need, I'd rather show it. So here you would subtract 7 and divide by 3. So these are my x-intercepts. To find a y-intercept, what do we do? Good job. Let x equal 0. So you go negative 2, that's 5 times negative 4 times 7. So use your calculators. That one's a big enough number. Well, actually, you probably could get away with that one. What's 2 times 5? 10. What's 4 times 7? 28, right? I'm just doing the 4 times 7. So 10 times 28, 2 negatives, so that's 280. All right. Questions on part A? All right, try part B on your own. If you can handle it, can you just look at it and tell the x-intercepts? I got x was 7 and x is -1. Do you see how fast you can do those? Because I'm just doing it in my head. Now to do the y-intercept, that one's a little bit harder. And be careful with the exponent. Because if this had been, say, x minus 1 squared, you'd be squaring the negative, okay? Be careful. So did you get -28? Yes. Okay, so let's look at example 5. It says, write the equation of the cubic polynomial shown. So what you're going to do is you're going to start with your x-intercepts. So if you know the x-intercepts on the cubic, you're going to write down their factors. This time, do you see that it's not, there's no dot, there's no clear dot that where the y-intercept is, but they gave us another clear point. So you're going to use 1, 8 to find A. Don't assume the y-intercept. Do you see it's not, if this is 2, 4, 6, 8, 10, that's not clearly at the 12. It looks like it's a teeny tiny bit below that. All right, so I'm going to pause a moment. So I'm getting 8 equals A times 1 plus 1 times 1 minus 2 times 1 minus 3. So I'm getting A is 2. So then this is going to be y equals 2 times x plus 1 times x minus 2 times x minus 3.